Good afternoon.
Hello. Oh, oh boy. Today is an anniversary day, everybody. Can anybody remember where they were on this day 52 years ago?
I wasn't even thought of.
How's that work?
Today is the 52nd anniversary of the first man on the moon. It is really strange now, given today's modern technology. When they went to the moon, the computer in your iPhone is more powerful than the computer that was on board the lunar module.
That's crazy.
Yeah, if you ever get the opportunity to watch a documentary about that, the part of it that is kind of a nail biter, and you got to be wondering, like, oh my gosh, these guys, I mean, it's a testament to their skill and dedication. When Neil Armstrong was landing on the moon, you can imagine that the lunar lander is pretty flimsy. It's not, there's a copy of it in the Air and Space Museum in the Smithsonian. And if you were to see it, you'd be surprised. Even though there's a lot of technology in it, it looks like something your 10-year-old put together in the backyard with cardboard and a bunch of duct tape. And when they were landing on the moon, they didn't have, how should I put it? There was no satellites orbiting the moon. They didn't not have a detailed map of the area that they wanted to land in. So when Neil Armstrong was landing the lunar module, as he got close to the surface of the moon, he began to realize that the surface where they were going to land was really rough. It was rocky. There was a lot of craters in that location. And so obviously, they didn't want to land on a rock. They didn't want to land on the side of a slope of some kind. And the problem is as they were getting close to the surface, Neil was having to literally drive the lunar module over the surface of the moon in order to locate a flat and large enough area to land in. The problem was, and this is where you should watch the documentary because you got to be thinking, oh my God, this is like intense. He was running out of fuel. And he landed with literally about 3 seconds of fuel left over. And when he finally radioed back to Earth, his famous words were, tranquility base here, the Eagle has landed. You could almost hear and see the sigh of relief of everybody that was on Earth, because you got to remember 1969 technology is nowhere near what it is today. If those astronauts had crashed on the moon and died, their bodies would still be there today. And how do you think that would affect the American psyche if they knew that every time they went out into their backyard and looked up at the moon, there was 2 dead Americans lying on the surface of the moon. Pretty intense stuff. And because they didn't have any computers on board the spacecraft, the lunar module itself, everybody, they are having to calculate complex math problems as it relates to aeronautics, flight. They're having to do this in their head. You can train your brain just like you can train a muscle. And as crazy as that sounds, yes, you can train your brain to do complex math problems without the aid of a computer. Obviously, you're going to be slower than a computer, but you can still do it.
I have a quick question off the subject. Did you receive my email about me having to run down to LA and pick up my husband from the airport?
Yes. I'm sorry I didn't answer you right away. I read your message at like 3 o'clock in the morning.
Okay.
And, I didn't have time to answer you appropriately at the moment. I was kind of busy at that time.
No, that's okay. I've been trying to figure it out, as the days have been going by, how I'm going to do it. So I have my iPad, and I was going to get on while I was driving down there and just listen to you because I have data. And then I was going to just take all my notes and stuff. And while I'm waiting at the airport, once you send that email out, I was just going to try to just put it on a regular piece of paper. And then when I got home, print everything out and then transfer my answers over. If you think that would, you may be excused, Logan. Sorry, my son's asking me if you can be excused.
The good thing is that I'm not going to be sending you guys any more handouts. You've got everything that you're going to need for this exam. So the only thing you're going to get from me now is just the exam itself and the answer sheet.
Okay. And I forget what time or around what time you said you were going to be sending that out.
I would like, well, I'm going to go over that here in just a few minutes. I want to put it on the recording so that everybody hears it.
Perfect.
Yeah, and because as you might imagine, I'm also getting messages from students, and we've all been doing this online thing now for over a year, and it's raised an entirely new set of student related issues. And I'm just curious because many of you guys have taken classes that were conducted on Canvas. And so I guess what I want to know is that in regards to is Canvas, like, say, any easier? Do you have less technical problems with Canvas? Are you able to communicate with the instructors whenever and wherever you want to? Is Canvas that much better than conducting a class on Zoom?
I actually like Canvas, but I've used Canvas for several years in my classes. I've had actually in-class instruction and coupled with going to class. And so I find it, once you get in your groove and if the teacher, puts the stuff in, and helps the students navigate through it, it's really easy actually I actually kind of like doing it that way, and the grade book's in there too. So the students will be able to see their grade or whatever. Right. So I like Canvas. I like going to class, but having Canvas as well. So that's just my opinion.
Okay. Well, I'm only asking because since we've been conducting online classes, I have had to deal with repeated issues related to students telling me, oh, I didn't get the message, or, I've been here every day and yet, I've not received anything. And about, I would say more than half the time, what I discovered is that I was sending material to their COS address, and they were using a different address, and they never notified anybody that that's what they were doing. And so I've had many different kinds of student issues that I never saw before we started teaching online.
So I think the cool thing about the announcements on there, you can put anything on the announcements, and every single student will have like a little bell or something that pops up that shows that the teacher said something and you need to go read it. And so if, you put on there, this is what we're doing.
The reason I'm not overly concerned about it right now is because on Thursday, when you guys start returning the exam sheets to me, you guys are my very, very last class that I'm teaching. After Thursday, that brings an end to a 32-year career in teaching. So you guys are the last ones.
Well, congratulations. You get to retire from teaching?
Yes. I've had what I consider to be an absolutely amazing career in teaching. It's been very personally rewarding, as well as just plain fun for me. For me personally, teaching was one of those jobs I just couldn't believe they were paying me to do that.
Well, congratulations on all your years.
Yeah, but hey, I'll cash the check. So
yeah.
But yeah, it's been a thoroughly enjoyable career for me. And I thought it would be kind of emotional for me, but because we've been teaching online for over the last year, it has, I think my retirement from teaching would be different if I were actually in a classroom with you. It would be a little emotional for me, but this online stuff, in a way, it's kind of sad that I have to end on this particular way, but at the same time, teaching on Zoom over the last year, it's kind of like prepared me for retirement. It's not as bad, because here I am, in one of my studies, and as soon as I turn the computer off, that's it. Don't have to drive home, don't have to talk to a student after class. So it's kind of, the Zoom is to me, it's impersonal. Okay, I think we're all here. Let me get started.
Recording in progress.
Okay, everybody. A few comments before we get started on the study guide here. This is the last week of the class. The class is officially over with this Thursday. And so I would like today to get through as much of the rest of the study guide as I can, because what I would like to do tomorrow is whatever I have left to cover, I'll do that, but I will also go over the exam tomorrow, okay? And what I would like to do is send out the exam and the answer sheet to everybody on Wednesday night. Okay. So I'll send it out to everybody probably sometime after 6 p.m. on Wednesday. And as usual, fill your answers out on the answer sheet and then send it back to me by Thursday. Okay. If possible, I would like to try and get everybody's answer sheet back by Thursday afternoon. And in order to accommodate those of you who work until say 5 or 6 in the evening, I'm going to send the exam and the answer sheet out on Wednesday night. And I would like to have all of the answer sheets returned back to me by Thursday night at 9 p.m. Okay. So that way I can get through the grades and get them submitted by Friday, and then also send out your respective emails with your grades on them. Okay. So here's the plan. I'm going to finish no later than tomorrow. I will also go over the exam tomorrow. And then tomorrow night, it'll be after 6 p.m., but after tomorrow night, I will send out the exam and the answer sheet. And then I want you to return the answer sheet to me by Thursday evening, 9 p.m. at the latest, okay? If for any reason you're late, everybody, or if you somehow forget or you don't send it back to me, I have to submit grades by Friday. So if for any reason I don't hear from you and I can't get a hold of you and I don't have an answer sheet, I have to submit grades. And so if there is an issue and you either need a grade changed or something like that, it's likely to take a few weeks to get that straightened out. So please have the answer sheet returned back to me by Thursday evening, 9 p.m. Okay. The second topic I would like to talk about before we get going on the study guide here is the extra credit that'll be on the final exam. And the extra credit, I sent out to all of you some examples of ion combinations and the rules that I stated in the handouts that I want you to follow when you write your answers. So as far as the ion combinations go, everybody, that is going to be the extra credit on exam 3. Okay. And it is not mandatory. You do not have to do it if you don't want to, but give it a try. You might get a few extra points out of it. The 3 rules for writing the correct answer are that 1, only opposites mix. So you can only mix a positive ion with a negative ion. That's how that works. Rule number 2 was proper ratio. So in the case of water, the proper ratio was H2O. 2 hydrogens, 1 oxygen. That's the proper ratio. The third rule was, in your answer, write the positive ion first. Hydrogen is a positive ion. Oxygen is a negative ion. So hydrogen is written first. You don't see OH2. You see H2O. Okay? So those were the 3 rules. The ions that you are going to be combining, everybody, are going to be taken from the examples that I gave you. So you're not going to see anything new, okay? They're going to be taken from the ones that you already have in the handouts. All right. If you have to use, for instance, hydrogen and you mix it with oxygen and you come up with H2O, everybody, you can also reuse, say, for instance, either hydrogen or oxygen. So you can mix, for instance, you can mix hydrogen with fluorine. Fluorine is a negative ion, and hydrogen is positive. So hydrogen is a +1 ion. Fluorine is a -1 ion. So they will mix at a 1-to-1 ratio. And the answer, writing the positive ion first, will be merely HF, hydrogen fluoride. Okay, so you can reuse, say, for instance, one of the elements, in this case hydrogen, and combine it with something else that is acceptable. Okay, so if sodium, which mixes with chlorine on a 1-to-1 basis, you can also use chlorine and mix it with hydrogen. Chlorine is a -1, hydrogen is a +1. Your answer is HCl, or hydrogen chloride. It's an acid. Okay, you don't really want to come into direct contact with it, but anyway, it's an acid. So once again, you can reuse elements to combine with something else. Okay, there's going to be I will only accept a maximum of 10 possible answers. And I will take the first 10, because what's happened in the past is somebody will write out 30 different combinations in the hope that I will pick out 10 of them that are correct. That's not how this is going to work. Even though there's space for only 10 answers, and you somehow manage to cram in there 20 or 30 different combinations in the hopes that you'll get 10 of them correct, I am merely going to correct the first 10. After that, that's it. Okay, so don't fill the extra credit out with 20 or so extra answers. Just do 10. Okay, and so that'll be the extra credit. It's 10 extra points on the exam if you get it. So if you think about it, that's an entire letter grade. 10 extra points moves you from a B to an A, or possibly a C to a B, so on and so forth. Okay, so just 10 answers. All right, so I would like to start on the study guide. And I left off last week with common elements and common minerals. I'm not going to ask you any specific questions about, how much of, say, for instance, iron is in the Earth's crust. You do need to know that oxygen and silicon are the two most common elements in the crust, but don't worry about percentages or anything like that. As far as common minerals are concerned, I did ask you to note that native elements are the only group of minerals that are found in their natural state. In other words, when you dig up gold or say copper out of the ground, chemically, it's just gold. It's not gold oxide. It's not gold anything. The gold is merely embedded in the rock. So during the refining process, they're not doing anything chemically to the gold. They are merely pulverizing the rock in order to get the gold out of the rock. And the same thing's true with all of the other native elements, copper, silver. When you dig these things up, chemically, it's just silver or it's just gold. So that's a native element. The other mineral group I asked you to be familiar with was of the 8, everybody, this is the most common, and it should make sense to you because the 2 most common elements are silicon and oxygen. Therefore, the most common mineral group are silicates. Okay, silicates. All right. So on the study guide, everybody, I'm picking it up on page 2, number 7, where it says 3 types of volcanoes. Once again, volcanoes serve 2 purposes. One, they create new earth material. And 2, they're venting heat from the interior of Earth. Volcanoes are categorized according to size, physical size. So in the study guide, I have 3 types of volcanoes listed there for you. It says shield, composite, and then cinder cone. Shield volcanoes are the largest volcanoes on Earth. The single largest volcano on Earth is the Hawaiian volcano Mauna Loa. It's on the Big Island of Hawaii. And it's approximately 13,500 feet tall from the surface of the ocean upward. It's about 13,500 feet. That doesn't sound terribly big because there are mountains on this planet a lot bigger than that. So why is this the biggest volcano? Because there's a bunch of that volcano you're not seeing. It's underwater, everybody. That volcano is about as tall as Mount Everest is in the Himalayas. The difference is you're only seeing the top 13,000 feet of that volcano. There's 15, maybe 16,000 feet of it underwater you can't see. So that volcano is what? It's approximately 7.5 miles tall, but you're only seeing the top 2.5 miles of it. The single largest volcano in our solar system is the big one on Mars, Mount Olympus, Olympus Mons is what it's called. Our volcano on Hawaii, I just said, is 7.5 miles tall from the bottom of the ocean all the way to the top. Olympus Mons is over 15 miles high. That's a big volcano. It's big enough, everybody, you can see it with the unaided eye from space. It's that big. So shield volcanoes are the largest, and there's a specific reason why they are so big, which I will get into in just a minute. The composite volcanoes are slightly smaller because as we go down to cinder cone, everybody, cinder cones are the smallest of the volcanoes. To put the size in perspective for you, I already said that Mauna Loa on Hawaii is a shield volcano. The volcanoes that are in Northern California, Oregon, and Washington are composite volcanoes. And Mount Shasta in Northern California, it's near the Oregon border. That volcano is approximately 13,500 feet tall. It's not the tallest peak in California. Mount Whitney is, but it is still a big volcano and it's active. Just remember that here while you're living in California, enjoying our nice sunny days. Because if Mount Shasta were to explode, everybody, it would be dark for months. You probably wouldn't see the sun for a few months. Anyway, those are all composite volcanoes. Probably the single most famous composite volcano in Earth's history has to be the Italian volcano of Mount Vesuvius. It's right outside the city of Naples, Italy. And it is famous in history for burying the old Roman city of Pompeii in the year 79 AD. They recently discovered the city of Pompeii sometime in the late 1500s, and we've been excavating it ever since. There's approximately 1/3 of that city that's been completely dug up out of the ground. And when they dug it up, they not only found perfectly preserved buildings, they also found not human remains. That's not what they found. As they were digging in the ground and removing the dirt, you might say, they kept finding what were basically holes inside the earth, holes. And so sometime in the 1700s, maybe, I think it was early 1800s, somebody got the idea that before we destroy that hole and just dig up the earth around it, let's try filling it in with plaster of Paris and see what exactly these holes, because they were just odd. They were all over the place and they didn't know what they were. And when they filled in one of these holes with plaster of Paris, let it harden, and then they scraped away the dirt, they found out that these holes were where human beings had fallen over dead. They were the shapes of the people living in Pompeii. So when they scraped away the dirt and looked at the hardened plaster of Paris, what they saw was a human being. And the ash and the magma preserved the shape of their bodies perfectly. So when they scraped away the earth from around the plaster of Paris, they could actually tell this is a man, that's a woman, this is a Roman citizen, that's a slave. They even found the family dog. And in one rather touching scene, they found an entire family, mom, dad, and I think there was 4 children. And there was also a family dog, and there was another person with the family that, based on the way they were dressed, this was probably a slave girl, and she was pretty much like the nanny to the children. And all of these people were huddled together when they died. And that goes for the family dog as well. They had a German Shepherd. And if you ever go to Italy and you somehow manage to find your way towards the city of Naples, it costs about $30 or so to get into, because they've opened it up to tourism. You can actually walk through the parts of Pompeii that they've excavated. The really amazing part of that trip is that when you walk through Pompeii, everybody, you're going to be absolutely stunned and surprised when you look at these buildings, which have been perfectly preserved by the magma and the ash. They look like any small, modern, 21st century day village. You'd never know that these buildings you're walking in and out of are over 2,000 years old. They look like they were built yesterday. Also, when you go walking through there, not only was the building itself preserved, everybody, but the attachments to the buildings are also still there. And what I mean by that is there's a section of Pompeii that when you go walking through it, it was probably the area of Pompeii where there was a lot of shops. It was a commerce, the commerce area. It was kind of like their version of the shopping mall on Mooney Boulevard in Visalia. And so when you go walking through this portion of Pompeii, you can easily tell that this particular building was a bakery. How? Because the mosaic on the wall is still there. And it was how they advertised the business. So on the mosaic, there are images of breads and cakes and other items that you would normally find at a bakery. One of the buildings that I thought was kind of funny was there's the Roman equivalent of a Joe's Bar and Grill. And there's also the other one that was kind of funny to me is there's a building in there that was, how should I put it? This was the red light district of Pompeii, let's put it that way. And it turns out that the evidence indicates that the city of Pompeii was the Roman equivalent of a retirement community. And many of the people that lived there had some degree of wealth because the homes that they've dug up there are fairly large. There's swimming pools in people's backyards. And the buildings, the homes themselves are rather large. They have courtyards in them and whatnot. And keep in mind, this is before Christianity. So a lot of ancient Romans accepted prostitution was a normal part of day-to-day life in this time period. And so these businesses that I'm describing to you, everybody, they catered to women as well as men. There was no discrimination in that regard. They didn't see a difference in it. So women had as much of a choice in that matter as men did. And the reason I thought it was kind of humorous is because when we walked by the building and we saw the signs, the mosaics that advertised what this building was, you can imagine some of the images were pretty graphic. And Like I said, they cater to both men and women. So it's a interesting piece of archaeological history if you ever find yourself in Italy at some time in the future. So that's a composite volcano. The smallest volcano on this list are cinder cones. And California actually has a number of cinder cone volcanoes. However, you should thank your lucky stars that they are no longer active, because there is a reason why we have different sizes of volcanoes, and I'm going to get into that right now. What you need to know so far is the shield volcanoes are physically the largest, cinder cones are the smallest. Underneath that, it says number 8, eruptive activity. And what this means is this is the magma that is coming out of the volcano. Once again, I want to remind you, everybody, there is a definition here I want you to know. When it is still inside the earth, it's referred to as magma. Once it escapes out a volcano or a crack in the earth's surface, it changes names to lava. So lava is on the surface of Earth, magma is on the interior of Earth. It's the same substance, just changes names. So the eruptive activity is basically how violent is this eruption. That's what this is referring to. How violent is the eruption? Please notice that number 1 says Hawaiian. These are the quietest eruptions. They are the mildest. And there's a reason why shield volcanoes are the largest on Earth, because they typically display Hawaiian type eruptions. These are relatively mild eruptions. There's no big, huge explosion. So the reason shield volcanoes are so big is precisely because there's no big, huge explosion. Over hundreds and thousands of years, as this volcano erupts, it is basically dribbling this magma or lava out the volcano. And as the magma hardens and solidifies, the mountain just gets bigger and bigger and bigger as time goes on. The second type of eruption are strombolian, and these would be the eruptions associated with the California volcanoes, the Oregon and the Washington volcanoes. These are more violent than the Hawaiian volcanoes, and when they erupt, they do explode. And in 1980, Mount St. Helens erupted. Mount St. Helens is located in southern Washington near the Oregon border. And when it erupted, it literally blew off about 5,000 feet off the top of the mountain. So this is why these volcanoes are not as large as the Hawaiian volcanoes, because when it erupted, it literally just took 5,000 feet off the top of the mountain. So that's a heck of an explosion, everybody, to remove 5,000 feet off the top of a mountain. I don't even know if a nuclear weapon could do that. So that's how powerful these eruptions are. The third one, it's pronounced Pelayan. And of the three, everybody, Pelayan eruptions are the single most violent eruptions on Earth. And The name Palayan is taken after a volcano known as Mount Pelée. Mount Pelée is located on the island of Martinique, and it is in the Caribbean. So for those of you who like to take these boat cruises in the Gulf of Mexico, just remember all of those cute little islands that we all love going to are only there because South America is crashing into the southern end of North America. Remember me telling you earlier that there were two areas on Earth that were very active in regards to volcanoes. And I said the Gulf of Mexico region was one of them. The other one is around Southeast Asia. Australia is crashing into Southeast Asia. And as a result, it's creating the country of Indonesia, Papua New Guinea, and those thousands of islands that are located in that region of the world. Many of these islands in the Caribbean and around Southeast Asia are volcanic. So the Mount Pelée is located on the island of Martinique, and it erupted in 1902. And when it erupted, it killed pretty much everybody on the island of Martinique. There was one survivor, which is kind of a curious story because it turns out he was the town drunk, and he was in the local jail, and that jail was made up of cinder blocks, and there was no windows or anything like that in this jail cell. You see, what kills people in a volcanic eruption, everybody, is not the magma. It's, I guess, what you would call all the smoke and debris that comes out of it as well. If you've ever seen photographs or graphic illustrations of a volcanic eruption, you've noticed a large column of smoke coming out the top of the volcano, and it rises above the volcano. And when it rises, everybody, it will go up about 20 miles. And when this smoke and ash comes out of the volcano, originally it's about 2, maybe 3,000 degrees Fahrenheit in temperature. As it rises upward into the air, everybody, the temperature is going to get colder and colder. And as all of that smoke and debris starts to get colder and colder, it's going to get heavier and heavier. And so when that smoke column rises up and reaches around 20 miles high, the smoke and debris at the top of that column is now very, very heavy. And so it's going to want to collapse down on itself. When it does that, everybody, it's going to come down and then go down the side of the mountain at speeds of around 300 to 500 miles an hour. You are not going to get out of the way of this when it starts falling down. The reason it is so dangerous is because even though it has cooled down, it is still in the 500, 600, 700 degree range as it reaches the surface of Earth. So when it comes rolling down the side of the mountain, it is still at about 600, 700 degrees Fahrenheit. And it's moving at 500 miles an hour. You're not going to get out of the way of it. When it envelops you, this is gas and dust at 500 degrees. The dust has the consistency of talc powder. It's very fine material. When you take your first breath of air, you will incinerate your lungs, and that's how you die. 3 days later, when the magma finally rolls its way down the side of the mountain, that's when it finally covers you up, but you're already dead by then. So Palaean eruptions are the most violent. Now, what makes one eruption violent and one eruption quiet? It has to do with the acid content of the magma. One of the common elements in the earth is silicon. If the silica content of the magma is high, if there's a lot of silica in that magma, it's going to be violent. It makes the magma acidic. And so you're going to have a very violent eruption. So if you've ever seen images of people wearing what looks like tinfoil. They're wearing suits is what they are, but it looks like they're wrapped in tinfoil. The reason for that is they're protecting their bodies from the heat, because what they want to do is they want to walk directly up to the magma itself and get a sample of it, and then take it back to the lab and analyze it. And that's how they discover whether or not it's going to be a violent eruption. How much silica is in the magma. And that's what these tests are trying to determine when they get a sample of the magma. So Palaean eruptions are the most violent, and this is pretty much the kind of volcanoes that are circling around the Gulf of Mexico. So the next time you're on one of your Caribbean cruises, just keep that in the back of your mind. That is one of the most dangerous places on Earth to be if a volcano erupts. Okay. Number 9, and backtrack just a second here. I said earlier cinder cone volcanoes were the smallest, and there was a reason for that. And it has to do with the fact that cinder cone volcanoes typically display Palaean type eruptions. The reason cinder cones are so small compared to the other two categories is because when they erupted, everybody, they literally blew the mountain clean off the face of the earth. And the only thing left behind are these cinder cones. That is a violent eruption. Number 9, it says plate boundaries. These are the actual cracks in the Earth's crust. The most famous one here in California is the San Andreas Fault. Now, please notice that there are 3 types of plate boundaries. These boundaries, the difference between the 3 of them is based on movement. So as an example, everybody, the San Andreas Fault is what's called a transform boundary. And what that means, everybody, is on either side of the fault line, the boundaries are moving past each other sideways. They are moving like this. They are not moving like this or like this. They're moving sideways. And so that is a transform boundary. Even though it's a transform boundary and it's moving sideways past each other, when an earthquake occurs, many of you have experienced one here in California. It's pretty powerful when you think about it. But the energies that are released during these earthquakes, everybody, they are strong enough and powerful enough to push the Sierra Nevadas up out of the ground and create the Sierra Nevada mountains. The Sierra Nevada mountains are made up of granite, everybody. And if you remember, I said granite is formed inside the earth. So the Sierra Nevadas are not volcanic. The magma solidified inside the earth. Then the San Andreas Fault squeezed it up out of the ground. It also created the San Andreas Fault. It created the Great Central Valley. It squeezed it into existence. The only reason the valley floor is about 300 feet above sea level is because over the last few millions of years, there's been enough wind and rain to rinse the soil off the tops of the Sierra Nevadas, and the rivers have carried all of that mud and debris down here into the Great Central Valley and has basically filled the Great Central Valley up with mud. You're standing on approximately 2,000 feet of this debris that used to be on top of the Sierra Nevada mountains. And it's one of the reasons why we are so agriculturally productive. This is very good ag soil. The second kind of boundary listed there is a divergent boundary. This means the two sides are moving away from each other. And as they move away from each other, the crack in the earth obviously is getting wider and wider, and more and more and more magma come out of that crack. The single largest divergent boundary on Earth is dividing the Atlantic Ocean in half. The planet or the Earth's longest mountain chain, it's not the tallest, but it's the longest mountain chain, is completely underwater. You can't see it. And it runs down the middle of the Atlantic Ocean. It's a divergent boundary. And over time, everybody, the Atlantic Ocean is getting wider and wider and wider. Because you live on a round object, that boundary is literally pushing North America this way, and then it's pushing Europe and Asia that way. And because you live on a round object, they have to meet on the other side. So this means that over millions of years, everybody, the Pacific Ocean, which is currently the single largest feature on Earth, the Pacific Ocean is getting physically smaller, smaller, smaller. The Atlantic Ocean is getting wider, wider, wider. Okay, so the boundary that is at the bottom of the Atlantic Ocean is known as the Mid-Atlantic Ridge. It's a divergent boundary. There is a boundary, a divergent boundary on the surface of Earth that you can actually see with your own eye. And it is literally ripping East Africa away from the rest of the continent. If you were to look at a map of Africa, everybody, on the east side of Africa, there are a series of lakes. They are long and narrow. These lakes are actually the divergent boundary. Because they're on the surface of Earth, they have merely filled in with water from rain, and they have created lakes. But these are actually divergent boundaries. East Africa is moving away from the rest of Africa. This very same divergent boundary that is separating East Africa, it starts near Southern Africa and moves its way north up toward Egypt. As the boundary approaches the country of Ethiopia, it makes a slight, the boundary does, it makes a slight right-hand turn, and that boundary then continues northward, and it is creating the Red Sea. The Red Sea is a divergent boundary. It's kind of like that region of the world's San Andreas Fault. The difference is it's not sliding past each other, it's moving away from each other. So as that boundary passes through the Red Sea and moves up north, it's eventually going to come up to the Sinai Peninsula, where the boundary will pivot once again, and it moves northward up through the country of Israel. The northern end of this boundary is the Dead Sea. And the Dead Sea is the lowest place on the surface of Earth. The Dead Sea is over 300 feet below sea level. So any water that finds its way into the Dead Sea does not escape, because water only moves in one direction, everybody, and that's downhill. But the sea is already 300 feet below sea level. So no, it's not going to roll uphill and eventually end up in the Mediterranean. That's not how that's going to work. But because it finds its way into the water gets its way into the Dead Sea, it's bringing with it debris, you know, the dirt, much the same way when the rivers come out of the Sierra Nevadas and they deposit all of their mud and debris here in the Central Valley. The same thing's happening in the Dead Sea. And so as a result of this, the Dead Sea is about 20 times saltier than the Pacific Ocean. And so when the salt content of the water is really high, you have a tendency to float. You can't sink in the Dead Sea. So if you were to go into that water and lie flat on your back, you wouldn't sink. You would just lie there on the surface of the water, because the density of the water has been changed because of all that salt that's in the water. So it's very possible that the big guy did walk on water. The third plate boundary, everybody, is a convergent boundary. And this is where the two sides of the boundary are colliding with each other. There are two possible outcomes of this collision. And the two possible outcomes are based on the density of the rock underneath each side of the boundary. So if the two sides are of equal density and they collide with each other, it's the equivalent of having two 18-wheel big rigs collide with each other head on at 100 miles an hour. There's going to be a lot of destruction, and the two trucks are going to squash each other because they're both the same size and weight. If the two bedrocks are different in density, one of them is heavier, one of them is lighter, the heavier one is going to ride over the top of the lighter one. So now you don't have two big rigs colliding with each other. What you have is an 18-wheeler about to have a head-on collision with a Volkswagen. And so the Volkswagen is going to get squashed. To give you some idea of what the outcomes look like, the country of India was in the ancient past attached to the South Pole. It broke away from the South Pole and it began migrating in a northward direction, where eventually it's going to collide with Southern Asia. Now, even though Asia is physically larger than the country of India, the rock underneath India and the rock underneath Asia are of equal density. When the collision occurred, they are creating the Himalaya mountains. They're pushing the ground up. In the last 25 years, people that have climbed Mount Everest have come back down the mountain and they have brought rock samples with them that show fossilized tropical fish in the rock. This is at the top of Mount Everest, where there's nothing but snow and ice up there. And they're finding fossilized tropical fish. The tops of the Himalaya mountains, everybody, were below sea level at one time, and they were underwater in the tropics. And then India came along and crashed into Southern Asia. The second kind of outcome is the one that creates most of the volcanoes on Earth. This is the one where you have a heavy rock colliding with a lighter rock. Even though we are talking about two rocks colliding with each other, everybody, they're going to grind into each other. If you do this with your hands for even a few minutes, you can feel the heat being generated on the palm of your hand. Now, magnify that heat sensation that you have. Suppose one hand is Asia and another hand is another continent, and these two rocks are rubbing against each other because they're colliding. The heat that is generated from that collision, everybody, is hot enough to melt Earth. And so it's creating magma. Magma is liquid. It's inside the Earth, and it is surrounded by solid rock material. Liquids are less dense than solids. What this means, everybody, is because the liquid magma is less dense than the surrounding rock, it wants to float upward toward the surface in much the same way a bubble rises in your soda can. Once that magma reaches the surface, it changes names to lava, but it's going to start spilling out and spilling out and spilling out. And over tens of thousands of years, it's going to create a volcano. Most of Earth's volcanoes are created in this fashion. What I want you to know for the exam is when these two sides collide with each other, the area right here that is between these two continents that are colliding with each other is called a zone of subduction. One of the continents is being subducted, which means it's being pushed underneath, and the other one is riding over the top of it. That's the grinding motion that is going to create the volcanoes. Most of Earth's volcanoes are found in association with zones of subduction. The single largest zone of subduction, everybody, completely circles the Pacific Ocean. Mount Fuji in Japan is the product of one of these collisions. The volcanoes in the Philippines are the result of one of these collisions. And all of those volcanoes located in Alaska are the result of these collisions. So the zone of subduction that completely circles the Pacific Ocean, everybody, is oftentimes called the Circum-Pacific Ring of Fire. Okay? And we should all be thankful that of the approximately 2,000 volcanoes on Earth, the vast majority of them are underwater. There's only about 500 volcanoes on the surface of Earth. Most of the rest of them are under the oceans. And so you should be thankful for that. Okay. Number 10 is the geologic time scale. And here's what I want to do, everybody. I'm going to finish tomorrow by covering the geologic time scale real quick, and also number 11, the two theories about Earth. That will only take me about 10 or 15 minutes to cover those two. And then I will go over exam 3 tomorrow, answer any questions you might have about the extra credit or the exam itself, okay? So the plan for tomorrow is to finish the study guide number 10 and 11, go over the exam, And then tomorrow evening at around 6 o'clock, give me a few minutes one way or the other, but around 6 o'clock, I will send out the exam and the answer sheet. And I will hopefully get all of your answer sheets back by Thursday evening, 9 p.m. Okay? So unless anybody has any questions, I will see all of you tomorrow.
Thank you.
Okay.
Recording stopped.
Bye-bye.
I have a question.
Yeah.
I didn't get my results for the last test again, and I've been sending you emails. I don't know if you got my emails.
I did send you your grade. Is that what you're asking about, your grade?
Yes. Oh, you did send it to me?
Yeah, and I even responded to you. Here, let me see if I can. Let's see.